Hello guys, I'm Mr. Brain. Today we're gonna see 6 amazing facts that will blow your mind. The first one, did you know that the Eiffel Tower can be 15 centimeters taller during the summer? This is because when a substance is heated up, its particles move more and takes up a larger volume. This is known as thermal expansion. Conversely, a drop in temperature causes it to contract again. The mercury level inside a thermometer, for example, rises and falls as the mercury's volume changes with the ambient temperature. This effect is most dramatic in gases but occurs in liquids and solids as iron too. For this reason, large structures such as bridges are built with expansion joints, which allow them some leeway to expand and contract without causing any damage. 20% of the Earth's oxygen is produced by the Amazon rainforest. Our atmosphere is made up of roughly 78% nitrogen and 21% oxygen, with various other gases present in small amounts. The vast majority of living organisms on Earth need oxygen to survive, converting it into carbon dioxide as they breathe. Thankfully, plants continuously replenish our planet's oxygen levels through photosynthesis. During this process, carbon dioxide and water are converted into energy, releasing oxygen as a byproduct. Covering 5.5 million square kilometers, the Amazon rainforest cycles a significant proportion of the Earth's oxygen, absorbing large quantities of carbon dioxide at the same time. Third, some metals are so reactive that they explode on contact with water. There are certain metals, including potassium, sodium, lithium, rubidium, and cesium, that are so reactive that they oxidize instantly when exposed to air. They can even produce explosions when dropped in water. All elements strive to be chemically stable, in other words, to have a full outer electron shell. To achieve this, metals tend to shed electrons. The alkali metals have only one electron on their outer shell, making them ultra keen to pass on this unwanted passenger to another element via bonding. As a result, they form compounds with other elements so readily that they don't exist independently in nature. Fourth, a teaspoon of neutron star would weigh 6 billion tons. A neutron star is the remnant of a massive star that has run out of fuel. The dying star explodes in a supernova while its core collapses in on itself due to gravity, forming a super dense neutron star. Astronomers measure the mind boggling large masses of stars or galaxies in solar masses, with one solar mass equal to the Sun's mass. Typically, neutron stars have a mass up to 3 solar masses, which is crammed into a sphere with a radius of approximately 10 kilometers, resulting in some of the densest matter in the known universe. Fifth, Hawaii moves 7.5 centimeter closer to Alaska every year. The Earth's crust is split into gigantic pieces called tectonic plates. These plates are in constant motion, propelled by the currents in the Earth's upper mantle. Hot, less dense rock rises before cooling and sinking, giving rise to the circular convection currents which act like giant conveyor belts, slowly shifting the tectonic plates above them. Hawaii sits in the middle of the Pacific plate, which is slowly drifting northwest towards the North American plate, back to Alaska. The plate's phase is comparable to the speed at which our fingernails grow. Chalk is made from trillions of microscopic plankton fossils. Tiny single-celled algae called coccolithophores have lived in Earth's ocean for 200 million years. Unlike any other marine plant, they surround themselves with minuscule plates of calcite. Just under 100 million years ago, conditions were just right for coccolithophores to accumulate in a thick layer, coating ocean floors in a white ooze. As further sediment built up on top, the pressure compressed the coccoliths to form rock, creating chalk deposits such as the White Cliffs of Dover. Coccolithophores are just one of many prehistoric species that have been immortalized in fossil form. But how do we know how old are they? Over time, rock forms in horizontal layers, leaving older rocks at the bottom and younger rocks near the top. By studying the type of rock in which a fossil is found, paleontologists can roughly guess its age. Carbon dating estimates a fossil's age more precisely, based on the rate of decay of radioactive elements such as carbon 14. Okay guys, that's all for today. If you like this video, subscribe, share and comment below. Thanks for watching.